Across the vast reaches of the cosmos, life crafts solutions that defy expectation, but nowhere is evolution more whimsical or more enchanting than here on the warm oceanic world of Kepler-22b, a planet covered by gentle seas, glowing marshlands, and forests of cyan reeds that whisper with every breeze. Suspended above the wetlands, drifting like living lanterns, are transparent orbs. Bubbles, not just floating through the air, but occupied. Inside each shimmering sphere is a small amphibian-like creature, legs tucked beneath its round, compact body, skin glowing with hints of blue. A creature that does not simply hop on land, but hops inside its bubble. These are the bubble hoppers, one of Kepler-22b's most iconic species, tiny architects of air and water, living their entire lives inside floating membranes that drift wherever the wind carries them. How do they breathe? How can a bubble be strong enough to survive storms? Why would any animal evolve to use a bubble as both home and vehicle? Tonight, we dive deep into the floating ecosystems of Kepler-22b, a world where gravity is gentle, the atmosphere dense, and where the boundary between sky and sea blurs into a playground of drifting spheres. Kepler-22b is a super-Earth roughly 2.4 times our planet's radius, orbiting its star within the habitable zone. Its atmosphere is thicker than Earth's, almost cushion-like, creating a world where the air feels buoyant and sound travels with soft clarity. Temperatures are warm and stable. Seasonal shifts occur, but the oceans moderate nearly everything. Storms are slow-moving, drawn across the surface like ink spreading through liquid. These conditions give rise to extraordinary ecological systems. Shallow seas filled with floating plant mats, tidal reef meadows glowing with bioluminescent algae, reed forests taller than buildings, flexible as willow branches, aerosol-rich air saturated with microscopic plankton, continuous humidity, perfect for creatures needing moisture to breathe. And above all, the air-tide layer, a region where rising warm air meets cool ocean vapor. Here, natural bubbles form constantly, stable, long-lived, and surprisingly resilient. It is in this mystical atmospheric layer that bubble hoppers evolved. To them, bubbles aren't toys. They are ecosystems, shelters, and wings. Millions drift across Kepler-22b's shallow seas during the warm season, creating the illusion of glowing beads sliding across the sky. But the bubble hopper never sees this from the outside. To them, the bubble is the world. At first glance, a bubble hopper looks like a frog sculpted from soft, translucent jelly, round-bodied with slightly water-filled skin. But look closer, and their uniqueness becomes clear. They are palm-sized, weighing only a few grams. Their limbs are short but powerful, built for sudden hops. The webbing between their toes glows faintly, especially in shade. Their skin is thick with miniature pores that constantly release a wet mist. This keeps the bubble moist inside and helps regulate oxygen exchange. Their eyes provide nearly 360-degree vision, allowing them to navigate the bubble's internal surface and detect predators from outside. Bubble hoppers hop inside their own microenvironment. Each jump pushes against the air inside the bubble, transferring force to the membrane. The result? The bubble moves instead of the hopper. From outside, it looks like a lantern drifting unpredictably. From inside, the hopper is steering. Behaviorally, bubble hoppers are gentle, curious, and surprisingly dexterous. Their limbs allow them to paddle through their bubble as easily as an otter glides through water. Everything about them, anatomy, behavior, instinct, is tuned to life inside a tiny drifting sphere. But how do they construct these bubbles? The answer is astonishing.
To understand these animals, we must examine their bodies, which have evolved not for land or sea, but for a hybrid of the two. 1. Bubble glands, living soap factories. Bubble hoppers produce bubbles using two specialized throat glands that secrete a surfactant-rich mucus. This mucus forms the basis of the bubble's membrane. On Kepler-22b, this natural mucus combines with airborne plankton and ocean vapor to form membranes far stronger than Earth soap bubbles. Some bubbles last weeks, even months. 2. Internal moisture system. Inside the bubble, the creature maintains a thin layer of humidity. Skin pores and gill-like side folds exchange gases through this moist film, similar to amphibians on Earth. This means that the bubble is not just shelter, it is part of their respiratory system. 3. Hydrospring hind legs. Their hind legs store energy using spiral cartilage fibers. A single hop inside the bubble can shift the bubble several meters or send them shooting upward on a thermal column. 4. Gas bladder navigation. Bubble hoppers have a small internal gas bladder filled with lighter-than-air compounds created during digestion. By adjusting this bladder, they control vertical position. Inflate, bubble rises. Deflate, bubble descends. This grants precise altitude control. 5. Pressure sense organs. Around their bodies are tiny ridges filled with nerve endings that detect bubble thickness, membrane tension, approaching predators, wind shifts, resonance vibrations. They know immediately when their bubble is about to rupture. 6. Adhesive toe pads. Their toes have pads coated in a thin adhesive fluid. This allows them to grip the membrane without puncturing it, like a gecko with water-sensitive feet. 7. Protective body shape. Their round body disperses impact evenly, ensuring that if the bubble crashes into vegetation, both hopper and bubble survive. Every aspect of their biology, from mucus chemistry to bubble resilience, has evolved in perfect synchronization with the floating ecosystems of Kepler-22b. The process of bubble construction is both delicate and beautiful. Step 1. Collecting moisture. A hopper rises through humid air layers, collecting vapor on its skin. The thicker the moisture coating, the easier the bubble will form. Step 2. Surfactant release. Next, they excrete a thin film of mucus from their throat gland, mixing it with the humidity until a shimmering patch forms around their body. Step 3. Inflation. They then perform a special throat pump, exhaling into the forming membrane. Slowly, a dome takes shape. Step 4. Pinch and lift. Once large enough, they pinch the forming membrane between their feet and expand it outward with a hop, sealing the sphere. Step 5. Balancing the bubble. They regulate the thickness of the bubble by licking the inner walls or applying more mucus where needed. This process can take as little as 5 minutes for experienced adults. Juveniles take much longer, often creating misshapen bubbles that wobble like uneven orbs. But a bubble built correctly is remarkably durable, able to glide through the air for days. The flotation is not magic, but physics elegantly exploited by biology.
Life for a bubble hopper is simple, rhythmic, and peaceful, at least when predators are not close. Their daily activities include steering their bubbles. A hop to the left makes the bubble drift right. A hop upward pushes the bubble downward slightly while rising with the air. Hoppers have mastered this system instinctively. Feeding. Bubble hoppers feed primarily on airborne algae, drifting spores, microworm larvae carried by breezes, and pollen clouds floating high above the wetlands. They capture food with sticky tongues or by pressing items against the bubble's inner surface. Grooming their bubble. Many species keep their bubbles immaculate, licking the walls clean, smoothing imperfections, and repairing weak spots. Social rolling. Groups of bubble hoppers often drift together, their bubbles touching lightly. They communicate through vibrations transmitted between membranes. To an outsider, it looks like a beautiful, slow dance of drifting lanterns. But danger is never far.
A needle-beaked avian predator, long, thin, and gliding silently with hardly a wing beat. Skylances pierce bubbles with their razor-sharp beaks, collapsing the membrane and leaving the hopper falling. Only the hopper's natural resilience and the thick vegetation below saves many from instant death. Defense against skylances? Rapid descent via bladder deflation. Hiding in bubble clusters. Bouncing the bubble erratically, producing loud membrane vibrations to confuse the bird's targeting. 2. The float fin burster. A fish-like creature that leaps from shallow waters, snapping at bubbles that drift too low. These ambush predators break bubbles with their muscular jaws. Defense against float fins? Maintaining higher altitudes. Clustering in large bubble groups. Thickening the membrane underside, using warning vibrations to alert nearby hoppers. Predation has shaped nearly every behavioral instinct the bubble hopper possesses, from sleeping patterns to migration routes.
Reproduction among bubble hoppers is gentle and communal. Courtship. Males inflate their throat sacs, producing a resonant hum that ripples the bubble surface. Females choose mates based on bubble stability and tone clarity, indicators of strong respiratory systems. Egg bubbles. Females lay eggs inside special nursery bubbles, thicker and denser than normal. These nursery bubbles float low over protected marshes. Larval stage, the floatlings. Babies emerge as floatlings, tiny, translucent, tadpole-like organisms that swim inside the bubble's moisture layer. They practice mini-hops, altitude control, membrane grooming, bubble reinforcement. As they grow, the floatlings perform their first independent bubble creation, usually clumsy, but essential. Family bonds. Bubble hoppers maintain small family clusters that drift together for years. Adults protect young, teach bubble repair, and respond to predator warnings collectively. On Kepler-22b, community means survival.
Though small, bubble hoppers shape entire ecosystems. They spread pollen between distant reed forests, distribute airborne algae, attract predators that balance herbivore populations, guide bubble-feeding symbiotic insects, transport microorganisms across wetlands. Some plants evolved specifically to interact with bubble hoppers, releasing spores that attach to bubbles, gaining long-distance dispersal. The more we study them, the more we uncover their importance in maintaining the rhythm of Kepler-22b's biosphere.
Kepler-22b's climate is shifting. Warmer oceans produce more violent storms. These storms threaten bubbles, tearing them apart faster than hoppers can rebuild. But bubble hoppers adapt, forming larger bubble flotillas, thickening bubble walls, cooperating to stabilize clusters, hiding in reed forests during storms, evolving new surfactant chemistry. Nature does not stand still, and neither do these tiny balloon travelers.
Meet Cerny, a young bubble hopper navigating life on her own for the first time. She wakes to a warm breeze, adjusting her gas bladder to rise above morning fog. She feeds by hopping upward inside her bubble, steering into spore clouds. Later, a skylance appears. Cerny vibrates her bubble rapidly, escaping just before a deadly strike. As the sun sets, she joins a bubble cluster settling near coastal reeds. Together, they form a floating community for the night. Cerny is just one among millions, but her journey mirrors the fragile, drifting dance all bubble hoppers share.
On Kepler-22b, where the sky is soft and the air is rich with life, evolution found a path no Earth creature ever followed. Bubble hoppers are a reminder that life does not simply adapt, it experiments. It dreams. It fills every corner of possibility with creativity. Inside each floating sphere is a tiny beating heart, trusting nothing but the bubble it built. And as the wind carries them across the oceanic world, we glimpse the incredible truth. Even the smallest beings can build the most delicate worlds and survive by embracing fragility rather than resisting it.